Hello everyone, and thanks for tuning in. Welcome to Algeomulus Prep Academy. Now, on to what we're going to learn today. The lesson for today is finding horizontal asymptotes using infinite limits. Horizontal asymptotes are horizontal lines on the graph which our function approaches. The definition of one would be as the limit x approaches positive or negative infinity, f of x would equal the limit. In our graph below, the dotted orange line is our horizontal asymptote, and the purple lines would be our limit. With horizontal asymptotes, the limit approaches very closely to the asymptote, For our first problem, we'll be showing you two ways how to do it to get the exact same answer. For our next example, we're finding the horizontal asymptote y of the function 8x minus 3 over x plus 5. First, what we will show you is the shorter and easier way to find the horizontal asymptote if the limit is approaching positive or negative infinity. So first, we identify the highest x power in the numerator and denominator. Taking a look at our problem, notice how the degree of the numerator and the denominator match. Since the function is approaching infinity, the rest of the function that doesn't have the highest x power isn't important. Looking at the x powers, we see that they are the same, 1. We can then cancel out the x's in our problem. So when we cancel out our x's, our answer would be 8, and the horizontal asymptote would be y is equal to 8. This method can only be used if x is approaching positive or negative infinity, since infinity goes on forever. Next, we will show you the longer method of this problem, which would still yield the same answer. In this method, you will divide the variable with the highest power in the denominator. Here it is x to the first power, seen in the denominator. Eight x over x cancels out to 8, as x over x cancels out to 1. This is where you plug in the x value, which is infinity. A number over infinity always equals 0. So that's why 3 over x and 5 over x equals 0 in the end when we plugged in infinity. After some simple algebra, we can see that the answer still equals 8. So our answer would be the horizontal asymptote would be y equals 8. You can see that both the long way, which uses the whole function, f of x equals 8x minus 3 over x plus 5, equals the same value as our short way, which only focused on the highest x power. Here we will check as x approaches negative infinity. Here we will use the same process as we did with x approaches positive infinity. We will plug in the infinity into the x values, and you can see that it will still equal the same result. After some simple algebra, you can see that the answer is the horizontal asymptote is y equals 8. When we graph this function, we can see that at the orange dotted line, that is our horizontal asymptote at y equals 8. And because of the function's denominator, we also have a vertical asymptote at x equals -5.
For this example, we are trying to find if there's a horizontal asymptote of the function f of x is equal to 4x squared plus 16x plus 64 all over 3x to the 5th power plus 9x to the 3rd power plus 81x. In order to find the horizontal asymptote, find the limit as x approaches positive and negative infinity. To find the horizontal asymptote, we can simplify the function by looking at the highest degree of the numerator and denominator. In this case, it's x squared over x to the 5th power. The reason for this is because as x approaches positive and negative infinity, only the leading coefficient with the highest power of variable matters. The function can be further simplified by subtracting exponents by using the quotient of exponents rule. This rule states that x to the m power over x to the n power can be simplified by subtracting m to n. In this case, x squared over x to the 5th power is equal to x to the -3rd power. To get rid of the negative power, you can make x to the -3rd power as 1 over x to the 3rd power. Now we can substitute in the positive and negative infinity into x. When simplified, we get two answers, 4 over infinity and 4 over negative infinity. Since any number over infinity equals 0, the horizontal asymptote is y equals 0. The graph shows that the horizontal asymptote is y equals 0. We can see that the function approaches 0 but does not reach 0.
For our third and final example, we are going to be finding the horizontal asymptote of f of x equals 5x squared plus the square root of 36x to the power of 6 plus 2x all over 3x cubed. What makes this problem unique is the fact that we'll be ending up with two horizontal asymptotes. So we start off with our function 5x squared plus the square root of 36x to the power of 6 plus 2x all over 3x cubed. In order to solve this, we are going to have to isolate the terms with the highest power on the numerator and the denominator, which in this case will be the square root of 36x to the power of 6 and 3x cubed. We do this since we're working with limits to infinity, making the rest of the function inconsequential. Thus, we are left with the square root of 36x to the power of 6 all over 3x cubed. We further reduce this function by rewriting 36x to the power of 6 as 6x cubed all to the power of 2. It is then reduced to the absolute value of 6x cubed all over 3x cubed. The absolute value of 6x cubed over 3x cubed can be expressed as both, for when x is greater than 0, 6x cubed all over 3x cubed, and for when x is less than 0, negative 6x cubed over 3x cubed. Like terms are then cancelled out, leaving us with 2 and negative 2. Thus, the horizontal asymptotes are y equals 2 and y equals negative 2. As you can see from the graph, the function 5x squared plus the square root of 36x to the power of 6 plus 2x all over 3x cubed get infinitely closer to the values of y equals 2 and y equals negative 2. Thanks for watching, and remember to subscribe to Algeomalus Prep Academy.